Hi guys, this is IGCSE O-Level Chemistry, Paper 2, Extended MCQs, Specimen 2023, Question 1. A gaseous substance is slowly cooled and the temperature recorded every second. The results are shown on the graph. At which point is the substance a solid? So we've got four positions A, B, C, and D. Let's study each one of them. So we are starting off with the substance as a gas. So A represents the gas cooling, and once the gas has cooled, it changes its state to liquid. States the change of state from gas to liquid. So the substance is now in the liquid state at B. Now the liquid is cooling, which is represented by C, and once it has cooled enough, it freezes. So when it goes from C to D, D represents the liquid freezing, and the part after that represents the solid cooling further. So we need to find out at which point the substance is a solid. The substance is a solid when it freezes, making option D the correct option for this question. Question 2. A gas is released at point Q in the apparatus shown. Okay, and we have got a damp universal indicator paper at the other end. Okay, which gas changes the color of the damp universal indicator paper most quickly? So we are talking about diffusion of gases. So the gas that would diffuse the quickest would be the one with the lowest MR, which would make this gas hydrogen. However, it needs to change the color of damp universal indicator paper. That means it has to be acidic or basic. Hydrogen is a neutral gas, so hydrogen is eliminated. Now, out of the three remaining gases, ammonia, carbon dioxide, and chlorine, all of them will change the color of the universal indicator paper because ammonia is basic in nature, carbon dioxide is acidic, and chlorine will bleach the paper. So we have, it would bleach the litmus paper, but it would have a similar effect on a universal indicator paper, most probably. So ammonia having the lowest MR would diffuse the quickest among these three, and it would reach the damp litmus paper and turn it somewhat blue. So ammonia would be the gas that would be the one changing the color of the universal indicator paper. However, the gas reaching the universal indicator paper the quickest would be hydrogen, but since it will not be changing the color, it is not the correct answer. Therefore, the correct answer for this question is option A. Question 3. Which statement describes the bonding in sodium chloride? A shared pair of electrons between two atoms leading to a noble gas configuration. Sodium chloride is an ionic compound, so it will not have a shared pair of electrons present. A strong force of attraction between oppositely charged ions. Yes, strong electrostatic forces of attraction defines an ionic compound. A strong force of attraction between two molecules. No, ions are present in the structure of sodium chloride. And a weak force of attraction between oppositely charged ions. No, the electrostatic force of attraction is strong, not weak, making option B the correct option for this question. Question 4. The lead in a pencil is made of a mixture of graphite and clay. When the percentage of graphite is increased, the pencil moves across the paper more easily. Which statement explains this observation? Graphite has a high melting point. The statement is true but does not suit the observation. Graphite is a form of carbon. Yes, it is an allotrope of carbon, but it does not explain why the pencil moves more easily. Graphite is a lubricant. Yes, layers of graphite are able to slide over one another, causing the material to act as a lubricant, and hence it would slide over slowly, slide over paper. And graphite is a non-metal. This is also true, but not a reason for why pencil moves across the paper more easily. So option C is the correct option for this question. Question 5. Which statement about metals is not correct? They conduct electricity because delocalized electrons can move through the metal. This statement is correct. That is how metals conduct electricity because they've got delocalized electrons. They consist of layers of atoms that can slide over each other. No, this is not true for metals. Actually, it is true for metals. It is true for metals. It is true for metals. They do have layers of atoms that can slide over each other, thus making them malleable. They have a giant lattice of oppositely charged ions in a sea of delocalized electrons. No, they have a set of positive ions in a sea of delocalized, not a giant lattice of oppositely charged ions. They only have positive charge ions present in a sea of delocalized electrons. So this is incorrect. And they have a giant lattice of positive ions in a sea. Yes, yes. So option C is the one that is not true for metals, making option C the correct option for this question. Question 6. Aqueous iron 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. What is the balance symbol equation for this reaction? So Fe2SO4 thrice would be iron 3 sulfate, NaOH would be the sodium hydroxide, FeOH thrice would be the solid precipitate forming, and Na2SO4 would be the solution of sodium sulfate. So all of these have the same reactants and products, but in different molar ratios. So we will have to check for the molar ratios. Since Fe2SO4 thrice reacts with NaOH. So NaOH, when it reacts with this, one iron ion would react with three hydroxide ions. So we have two iron ions present. So we would have 2 moles of FeOH thrice being formed. And when this reacts with NaOH, so there are 6 moles of NaOH required. So this would react with 6 moles of NaOH. And the other product that would be formed would be, there are 3 moles of sulfate ions and 6 moles of sodium ions. So there would be 3 moles of Na2SO4. So the equation that is matching to the one that we just made is given in option C, making C the correct option for this question. Question 7. Which information is needed to calculate the relative atomic mass of an element? The total number of protons and neutrons is the most abundant isotope? No, we would need the atomic mass for all isotopes to calculate the relative atomic mass, because the relative atomic mass is the weighted mean of the mass of the isotopes present, all the isotopes present. So this is incorrect. B, the nucleon number and the total number of isotopes. We would also need the percentage abundance of each isotope, the mass number and the abundance of each isotopes. Yes, the nucleon number would not give us the mass of the isotope. The mass number would give us the mass of the isotope. So this is what is required. And the atomic number of the abundance of each of its isotopes, no, atomic number will not help us. So we would need the mass number and the abundance of each isotopes. That would help us calculate the relative atomic mass of an element. So option C is the correct option for this question. Question 8. The equation for the reaction between sodium carbonate and excess dilute hydrochloric acid is shown when 26.5 grams of sodium carbonate reacts with an excess dilute hydrochloric acid. What is the maximum volume of carbon dioxide produced? So the molar ratio of sodium carbonate is to carbon dioxide is 1:1. So we need to find out the moles of sodium carbonate that reacted. So the mass of sodium carbonate is 26.5 grams. The MR of sodium carbonate is 106. When we divide this, we end up with the value of 0.25 moles. So 1 mole of any gas at RTP occupies a volume of 24 dm cube. So 0.25 moles of carbon dioxide would have a volume of 0.25 divided by 1 multiplied by 24, giving us a value of 6 decimeter cube, making option A the correct option for this question. Question 9. A volumetric pipette is used to measure 25 cm cube of 2 mole per dm cube aqueous sodium hydroxide into a conical flask. A burette is filled with dilute sulfuric acid. The equation for the reaction is shown. The reaction requires 50 cm cube of dilute sulfuric acid to reach the end point. What is the concentration of the dilute sulfuric acid in mole per dm cube? So in order to calculate this, first we need to find out the moles of NaOH that were present. So we had 2 mole per dm cube of NaOH. So 2 moles in 1000 cm cube. How many moles would be present in 25 centimeter cube? So this would become 25 upon 1000 into 2, which would give us a mole value of 0.05 moles. Now, the molar ratio of NaOH is to H2SO4 is 2:1. So, if the moles of NaOH is 0.05, it would make moles of sulfuric acid half of these, which would be 0.025. Now, the question asks, what would be the concentration of dilute sulfuric acid if 50 cm cube of it reacted? So, 0.025 moles were present in 50 cm cube of the acid used. How many moles would be present in 1000 cm cube? Because this would give us the concentration. So this would become 1000 upon 50 into 0.025, giving us a value of 0.5 mole per decimeter cube, making option A the correct option for this question. Question 10. The diagram shows a circuit used to electrolyze aqueous copper to sulfate. Which arrow indicates the movement of copper ions in the electrolyte and of the electrons in the external circuit? So, movement of copper ions would be from the anode towards the cathode, because copper ions would be produced from the anode when anode undergoes oxidation, and the copper ions would head towards the cathode where they would undergo reduction and get deposited. So arrow 2 represents the direction of flow of copper ions. This eliminates options A and B. Now, the flow of electrons. Since anode is where oxidation takes place and oxidation is removal of electrons, electrons will flow away from the anode. So the arrow that is flowing away from the anode is 3 and not 4, making option C the correct option for this question.